Okay, this is the last question on Core Pure 1, June 2023 Edexcel. And I think it's one of those questions that when you first see, you just go, oh my word, what on earth is going on here? There seems to be a lot of information and it looks like it could be quite complicated. But when you actually break down into it, it's not that bad if you kind of get your head around what's going on. So it's a matrix question, basically. And so you've got this colony of small mammals being studied, and in the studies the mammals are divided into three categories: newborns, juveniles and breeders. And you have this matrix kind of iteration, if you like, that works out how many there are of each type in a certain month. So first things first. The first question, the part A, which is the 1 marker, is an absolute nightmare. It's one of those questions where you kind of go, what do they want me to say? What on earth are they looking for me to say? And I think even as maths teachers, we kind of go, it's no right answer here. There's no kind of, it's really trying to work out what exactly am I looking for here? What's the purpose of this? So you've got these three categories: newborns, 0 to less than 1 month, juveniles, 1 to 3 months old, and breeders over 3 months old. And it says, state one limitation of the model regarding the division into these categories. A quick perfunctory look at it, there doesn't seem to be anything mathematically wrong there at all. There's no overlap or anything like this. So really it's just kind of coming up with something relating to the situation that you could criticise, where you could go, well, hang on a minute, this might not be so. So we're talking about small mammals being studied and the number of them. And so you've got newborns, juveniles and breeders. And I suppose the one thing that I would hone in on is the breeders and just going, right, over 3 months old, you are a breeder. Now, not every mammal that breeds to produce offspring is necessarily has to be over 3 months. You could have breeders that are younger than 3 months. You could have mammals that are over 3 months that don't breed, that can't produce offspring. So that will be the thing that I would focus in on. So they're really basically, with this model, it's very much over 3 months, that's when they produce offspring. And it's not a given that. So that's the thing I would criticise. I would say one limitation is that they're saying that all breeders are over 3 months old. And that's not necessarily true. Some breeders may be younger than 3 months, juveniles could be breeders. And equally, mammals that are over 3 months are not necessarily breeders. So that's the thing that I would focus in on and give my response to for that particular one. But it is one of those ones where you just have to kind of go, right, what could I kind of see that's not particularly necessarily true all the time for this model? Tricky questions to answer, I know, and nobody likes answering them. Even as maths teachers, they're just kind of like, what are we looking for here? Where's the hook on this that we can kind of look at? Anyway, let's get to the proper maths stuff here with the part B. So part B very much works on this little matrix equation. Just got to write it out. I should have done that beforehand to save myself some time. Don't know what that is there. What they use is little n. Quick rub this out. So newborns, juveniles and breeders. And this is just a little matrix equation that basically obviously tells us how to work out how many there are of each type after a particular month. Uh, 0.96. And we've got n, and so just get our head around this basically. So we've got a matrix that we multiply together, and it seems as though that then chucks out the number of newborns, juveniles and breeders for a particular month. And it's obviously dependent on the month before. So you've got n plus 1 here, and then N here. So this is the month before the one that you are evaluating. So it's basically this matrix times the number of newborns, juveniles and breeders for a particular month will give you, as an answer, the number of newborns, juveniles and breeders for the next month. So that's how this matrix equation works. Now, it gives us a few things. We've got to find out the number of mammals in the colony at the start of the study. And it tells us at the start of the study, there are only breeders. So there are no newborns, no juveniles, only breeders. It also says we've got after 2 months, the number of newborns is 48 and the number of juveniles is 40. So we're going to use that in a second as well. So the first thing we go for is right at the beginning, we know there are no newborns, no juveniles and no breeders. So if we literally just go, right, take this matrix, times it by this matrix by our first set of numbers, and initially we know there's no newborns, no juveniles, and a set number of breeders, which we don't know, which is how many there will be at the start. Okay? So that will give us our new set of numbers, basically, for our next month. So if I multiply this through, 0.02 against 0.0x gives me 2x. AB0 against 0.0x gives me 0. Okay, that against that. And then 0.4x against 0.9x gives me 0.96x there. So that will give us our number of newborn, juveniles and breeders after the first month. And then after the second month, we just times it by that again. So we're going to go 0.02, AB0, 0.48, 0.96. So if that's how many we got after the first month, after the second month, we times this by our matrix to get what the second month is. So multiplying that through, we get 1.92x. We get AB0 against that gives me 2ax. And then this against this gives me 0.96 times 0.96x. What's that? 0.96x, 0.9216x apparently. 6x. Now, so that's how many there are after 2 months. This is 1 month, our new numbers. This is 2 months, our new numbers for each of them. Now we know that after 2 months, we know the newborns is 48. So straight away we can go, newborns is that first one. So 1.92x is going to equal 48. So 48 by that gives us our 25. So now we know x is 25. We also know that the number of juveniles is 40. So that, 2ax, has got to equal 40. So we've done our part I. We've got to determine the number of mammals in the colony at the start of the study. We've worked out x is 25, and x is the number that started. So remember, no newborns, no juveniles, x number of breeders right at the start. So that's our answer for part I. There were 25 right at the start. And then now we know 2ax is going to be worth 40. It tells us there's juveniles after there. We know x is 25, so we get 40. 2 times 25, a equals 40. So a is 40 divided by 50, which is 0.8. And that is the thing we have to show for our part 2. Show that a is 0.8. Great. That's nice and easy. So it's literally use your matrix equation to start off with a set number, which we know 0, and some unspecified number, x, of breeders. Multiply it through to get month 1 results, multiply it through again to get month 2 results, and then use the facts they give you about month 2 results to work out your numbers. Okay, there we go. Right, I'm going to scribble that out, and rub that out, and we'll go to part C. And part C is a kind of standalone in some ways, in that it asks you to find the inverse of a matrix, and it's the inverse of our matrix that we just used. So I'm going to, just for my simple sake, just label that matrix A. So it's 0, 0, 2. A we now know is 0.8. B we don't know. 0, 0. Then 0.48. And then 0.96 there. Okay. And basically it wants us to find the inverse of that matrix. So as this is the matrix that tells us how many newborns, juveniles and breeders there are, you can be pretty sure we're going to be using that inverse at some point later on. But part C, in terms of B, we're just going to find the inverse. Now, just show enough steps so they can see that you're actually doing it nice and logically. So the first thing is, we find the determinant of this matrix. So we're finding a to the minus 1. We want to find the determinant of A first of all. So if we go through the determinant is quite nice actually, because when you multiply through the determinant, we are going to have 0. So remember, finding the determinant, you take each element on the top row and you times by that element. So we're going to take 0 to start with. Row and column crossed out, the determinant of 2 by 2. So because it's 0, it's going to be 0 times the determinant of that 2 by 2. Well, we can forget about working out the determinant of that 2 by 2. We're timesing it by 0, so it's going to be 0. And then it's going to be 0 times the determinant of the 2 by 2 when we cross out the row and the column that element is in. And again, because we're timesing by 0, you can ignore that, because you're going to get 0. So actually, the only elements in our determinant is going to be when we do this element, so 2 times the determinant when we cross out that column and that row of this matrix. And that's going to be 0.8 times 0.48 minus 0 times B, just minus 0 again. So that's really nice and it's simple. So we multiply that through and we get 0.768 for our determinant. Okay. Now let's go to our inverse procedure to work out our inverse. So the first thing we do is we replace each of the elements with the determinant that we get of the 2 by 2 when we cross out the rows and columns. Now, we don't have to times it by the actual element though. So you have to do this quite, you get quite quick at doing this, but it's easy to make mistakes on this. So they are usually for method marks. They're looking for a few of the elements to be correct for them to be able to go, okay, so you might have made a little slip up here. You're going to lose the accuracy mark, but we see you've got some of the elements correct, so you must have done it correctly. So if I'm going to do this, and apologies, I have done this before, just because you know how it is with these questions. If I'm standing here and I do it just off the top of my head, I'm bound to make an error somewhere. So I quickly scribbled it through. I made an error the first time I did it. I had to recheck and just go, where have I gone wrong? So if we do the elements that we replace that 0 with the determinant of this matrix here, and it's just going to be b times 0.6b. So we're going to get 0.96b for that first element. Then we're going to replace that 0 with row, column, that times that times that. So it's 0.8 times 0.96, which is 0.768. Okay? And then that element, row, column, that times that minus that times that, and we get 0.384. And we just work our way through. So I'm just going to fill these out if that's okay. Minus 0.96, 0, 0, minus 2b, minus 1.6, and 0. So that's going each element, replacing each element with the determinant of the 2 by 2 when you cross out the row and column of that element. So I'll remind you just one last time. So if I'm replacing that element, I go right, cross out its column and its row, and I've got 0, 0.8, 2, 0. That is minus 1.6 when you do determinant of that. Okay. We then apply our pluses and minuses. Remember, it goes plus, minus, plus, minus, plus, minus, plus, so it alternates each time. So if I apply the minuses to there, that's going to turn into, that's going to stay at 0.96b, that's going to turn into minus 0.768, that's going to stay at 0.384, this is going to turn into positive 0.96, that's going to stay at 0, that's going to stay at 0, this is going to turn into, stay at minus 2b, sorry. That's going to turn into positive 1.6, and that's going to stay at 0, obviously. And then final stage, we then transpose that, don't we? So all the rows become columns, so that I start off with the first row and just go right, so that becomes 0.96b, stays where it is, that becomes under here, so you just transpose it, 0.384, then 0.96, 0, 0, then minus 2b, 1.60. Okay, so that's the transpose done. So rows become columns. And then all we have to do is times by the determinant, and that will give us our, 1 over the determinant, sorry, and that will give us our matrix. Now 0.768 is, hello, what have I done in terms of this? It's 96 over 125. I thought much better to have this as a fraction because it looks like it's going to get messy otherwise. I know I've got decimals here, so never mind. So the 1 over the determinant is going to be 125 over 96. Okay, and we got our inverse. Whew! A lot of work in there for an inverse. Right, so now we've done that, we come on to the part D. Excuse me while I just move the question down so I can see what it actually says again. So it now says, given that the model predicts 1,015 mammals, in total at the start of a particular month, and then approximately 596 newborns, 464 juveniles and 437 breeders at the start of the next month, determine the value of B, giving you answers of 2 decimal places. So, if that's our matrix A, what it's basically saying is, if we take our matrix A and times it by a particular month, we end up with, where's numbers? 596, 464 for our juveniles, and 437. So it says if we take a particular month and multiply it by the matrix, we end up with these numbers. Okay. The other thing it told us right at the beginning is there's approximately 1,015 mammals in total at the start of this month. So this total must make 1,015. So x plus y plus z must equal 1,015. So that's the information they've given us there. Okay? And we've got to somehow work that out to be B, to work out what this B is that's still in our matrix. So, particular total 1,015, and when you multiply it that month, your totals x, y, and z, I've called these, you get these numbers. I know I used x previously, but it doesn't matter. Just, you know, you can call them A, B, and C. Well, I think they've used B there. Whatever letters you like, okay, to get that. Now, we are obviously using our inverse somewhere, and this is where it comes in. So if I put the inverse in front of this little matrix, remember, I've just called it A, you can call it whatever you like, but it makes it a little bit easier. I get this. Inverse times A, that's the identity matrix, so it just gives me x, y, z. So basically, x, y, z is going to be a to the minus 1, which is this, 125 over 96, and then, oh my word, I've got to copy this out again, 0.96b, 0.96, minus 2b, minus 0.768, 0, 0, 0 there, 1.6 there, and finally 0.384 there. Ooh. Okay. So a to the minus 1, that's that. Don't forget the 1 over the determinant at the front, times this. 5, 9, 6, 4, 6, 4, 4, 3, 7. So all I've done there is I replace the a to the minus 1 with the part of a to the minus 1 I found in part C. So I now know, if I multiply them together, that's going to give me my x, y, and z. So we're going to have to do a bit of multiplying again. I would keep the 125 over 96 out kind of, if you like, out the front. So we're going to get x, y, z is equal to 125 over 96 times, right, so all of that times all of that. Now I hope you don't mind, but I've just done that very quickly. And you get 745b plus 580. So I'm just doing that row times that, and that's going to give me my there, minus, I'm just checking, I think I've multiplied that in already. So apologies, I've done all the multiplying already. So that times that and then times by 125 over 96 gives me 745b plus 580 minus a really horrendous 54125 over 48b. I can combine them obviously in a second. And then I've got minus 596 for this second row, plus 10925 over 12. And then for the final row, it's a much healthier 298. So there's my x, there's my y, and there's my z, okay, that I must have started off with. There, okay. But I know they total to 1015, so I can add all them up. 745b plus 580 minus 54125 over 48b minus 596 plus 10925 over 12 plus 298 equals 1015. 1015, just squeezed it in there. So we got ourselves a nice equation, especially if we can find out b. And you work that through on your calculator, and I got b is, what did I get b is? 8516 over 18865. And sure enough, it asks for that to 2 decimal places. And when you do that to 2 decimal places, you get 0.45. Lovely. So, we've worked out what b is now. Final part. Whew. 13 marks this particular question. It is decided to monitor the number of newborn males, newborns now, and females as part of the study. Assuming that 42% of newborns are males, refine the matrix equation for the model to reflect this information, given a reason for your answer. So it's basically saying, go back to the model right at the beginning and change it to reflect the fact that now you want to split those newborns into males and females. So I'm just going to copy out the matrix equation again. Where is it? Let me just see. So newborns n plus 1. Stick with me for a minute. A little bit of copying out to do. 0.02. Our A's are 0. Well, I'll tell you what, I'm just going to put A and B in again, because, you know, what if these things change? 0.48, 0.96, there we go, times by n, j, n, and b, n. Right, there's our matrix, so we need to change this. So basically saying we need to split this, the newborns, into males and females. Right, so it seems logical, therefore, that we are going to have to split this, not so that instead of 3 entries here, we're going to have 4 entries. So it's going to be newborn males newborn females, and then still your juveniles and your... So we're now going to have that. And so therefore, if we're going to change this matrix equation, obviously our new thing here is then going to be new males, new females, whoops, juvenile and breeders. If we're now going to stick it so that we've got 4 entries here, we're obviously going to have 4 numbers in our rows. So we've got to be a little bit clever here and think about this. Now, how do we get the newborns? Well, that newborns comes from 002 times this. So when you times 002 by this, don't you just get 2 times the breeders? Because 0 times that, and 2 times the breeders. So basically, our newborns come from 2 times the breeders. So, doesn't that mean that, I'm just going to give myself a little bit more space here. We're going to still have to do just times in the breeders. So, 0, 0, 0. To get the number of males here, it's 0 times males, 0 times females, 0 times juveniles, and now we need to do a number times the breeders. Now normally it was 2 times the breeders, but because we just want the number of males, and they're 42% of them are males, 42% of 2 must go there therefore. And so that's going to be 0.84 there. So 0.84 times breeders will give us the number of newborn males, because it's 42% of 2. Now, for the next row, this will give us, the next row times this will give us the number of new females. And again, our newborns are 2 times the breeders, but we're going to be dealing with the number of females this time. And if it's 42% male, that means it's 58% female. So our rows are going to be 0, 0, 0, and then what did I say? 0.84, so it's going to be 1.16, isn't it? Because 58% of 2 is 1.16. So that deals with splitting this up into 2 separate ones. So that 2 is now split 0.84 for the males and 1.16 for the females. Yeah, 42% of 2 and then 58% of 2 for our females. Okay, quite tricky that, I think. Now then, we now need to move on. Now, we now need to get the juveniles here, we just do, the new juveniles, sorry, we just do AB0 times this. So that A times the newborns, the B times the juveniles. So we've got to go, okay, that A is times the newborns here. So when we do our 4-row one, we're going to have to do, first lot is going to times the males. So it was originally A times the newborns. So it's now going to be times the newborn males is going to be 0.42A. And then the next number will be how many we times the newborn females by, and it's not A anymore, we're splitting it into 0.5A. So that will make our A altogether. So basically it's kind of split 42% and 58% between the 2 newborns. Then it's still B times juveniles, and it's still 0 times breeders. Okay? And our final row will be for the breeders. So 0 times, when we do the breeders, it's that times there, so it's going to be 0 times the newborns. So we need to times the newborns by 0. So 0 times the newborn males, 0 times the newborn females. That will be 0 times the newborns altogether. Okay? Then we've got to do 0.48 times the juveniles, so it's still going to be 0.48 in there, and then 0.96 times the breeders, so it's still going to be 0.96 in there. That's going to be your new matrix multiplication. Okay, there we go. Now, it says refine the matrix model is given a reason for your answer. There's no need to estimate any unknown values for the defined model, but any known values should be made clear. So, kind of is a perfect explanation as to what I'm doing. So we might put a little bit in saying I have to split the newborns 42% males and 58% females. So we need a fourth column, fourth entry, and therefore we need to turn this into a 4x4 instead. And we need to make sure that the first two reflect the newborn males and newborn females. Now, on the mark scheme, I'll just quickly go over here and have a quick look at the mark scheme, what they said here. Oops, excuse me a minute. They didn't ask for any clarification other than that stood for newborn males and that got full marks. So there was no need to kind of try and waffle your way through it. I think they put there in there giving reasons just in case you didn't write out the new model. You actually tried to explain it. But yeah, that's how the model will look. So I think apart from that last part though, that wasn't too bad a question. It looked horrendous when you kind of saw the wording and just going, what on earth's going on here? But actually when you break it down, it wasn't too bad. Okay.